And here's the average pH for precipitation in the contiguous U.S. in 2002. By 2000, acid precipitation had affected most of the contiguous U.S., and so environmental regulations and new technologies have allowed many developed countries to reduce sulfur dioxide emissions so that this will not keep occurring, producing such acidic pitches. So, humans release many toxic chemicals, including synthetics, that were previously not known in nature. So, harmful substances can persist for long periods of time, and toxins are harmful in that they become more concentrated in successive trophic levels. Remember the 10% per level. So, in biological magnification of PCBs in a Great Lakes food web. So you can see phytoplankton 0.025 parts per million, zooplankton that consumes the phytoplankton 0.123 parts per million, smelt that consume the zooplankton, PCBs becoming even more concentrated with 1.04 parts per million, lake trout consuming the smelt 4.83 parts per million, and also smelt consuming the phytoplankton, and then herring eggs, gull eggs, 124 parts per million concentration of PCBs. And you can see how it increases the trophic food web. One pressing problem caused by human activities is the rising level of atmospheric carbon dioxide, a greenhouse gas causing the greenhouse effect. So the warming of planet Earth due to atmospheric accumulation of carbon dioxide, which absorbs reflected infrared radiation and reflects back towards Earth, warming the Earth. So CO2 is one greenhouse gas. Like the amount of moisture in the air also causes reflection, but that's done that since the beginning of time. It's only in the past 200 years, really, that CO2 has risen. Since the Industrial Revolution in the 1800s, the concentration of CO2 has been increasing as a result of the combustion of forest fuels and the burning of enormous quantities of wood removed by deforestation, clearing of the rainforest in South America, which has more or less come under control, but was out of hand in the 70s, 80s, and early 90s. From 1850 to today, CO2 has risen 17%. So how elevated CO2 affects forest ecology? The FACTS-1 experiment is testing how elevated CO2 influences tree growth, carbon concentration in soils, and other factors over a 10-year period. And this study just ended at Duke University. So rings of towers in the Duke University experimental forest emit enough carbon dioxide to raise and maintain CO2 levels 200 parts per million over present-day concentrations. And then the trees, soil, animals, and the niches around that were studied. And my oldest daughter got her master's degree at Duke University in Environmental Science Management and Work Project. Pretty impressive outcome. The greenhouse effect in global warming keeps the Earth's, so atmospheric CO2 keeps it at a habitable temperature. We have to have some atmospheric CO2 or it would be too cold. Increased levels of atmospheric CO2 are magnifying the greenhouse effect, however, with increased radiation can cause global warming and climatic change. So, depletion of atmospheric ozone. Life on Earth is protected from damaging effects of UV irradiation by a protective layer of ozone molecules in the atmosphere. And ozone is a type of oxygen. Okay. Satellite studies suggest that the ozone layer has been gradually thinning since 1975, probably due to chlorofluorocarbons, CFCs, which are now outlawed, chemicals used for refrigeration and as propellants in aerosol cans. Ozone absorbs UV irradiation, preventing much of it from reaching organisms in the biosphere. It is most apparent over Antarctica. So here, this is the thickness of the ozone layer over Antarctica in units called Dobsons. So you can see in 1955, it was much thicker to the early 2000s. So it's starting to come back a little bit here, and around 1992 was the lowest level. So how free chlorine in the atmosphere destroys ozone? Chlorine from PFCs interacts up here with ozone, which is O3, not regular molecular oxygen, which is O2, forming chlorine monoxide and oxygen. Okay, then two chlorine monoxide molecules react, forming chlorine peroxide. So when this interacts with sunlight, it breaks chlorine peroxide down to break down into oxygen and free chlorine atoms. And the chlorine atoms can begin the cycle again. So erosion of Earth's ozone shield, ozone hole over Antarctica is visible as a blue patch. So here's 1979. Here's October 2000. Scientists first described an ozone hole over Antarctica in 1985, and has increased in size as ozone depletion has increased. So you can see that it's very visible as the dark patch in these images based on atmospheric data. So you can even feel the increased radiation if you are in southern South America, such as Argentina. It's very easy. I was there once. It's much more easily to get a sunburn there than if you're in